let's talk about finding reference angles using degrees. So when you're finding a reference angle, you're going to end up finding an angle that's between 0 degrees and 90 degrees, also known as an acute angle. And it's going to be the angle that, if you take whatever angle you're given, it's the smallest angle measured to the x-axis if you're writing the angle in the standard sort of way. So like 100 degrees, if you draw it, it's going to end up like right there, right? Because there's 90 degrees, there's 0 degrees, there's 180 degrees, there's 270 degrees. So the reference angle is the angle measured from here to there, the closest x-axis. So basically, if you're in the second quadrant, you're measuring down to the x-axis. If you're in the third quadrant, you're measuring up to the x-axis. In the fourth quadrant, you're measuring up to the x-axis. In the first quadrant, it's usually just the angle you're given if it's already acute. So here, I need 80 more degrees. The way you can find it, basically, it's the difference between 100 and 180. So I do 180 minus 100 degrees to get 80 degrees. That would be my reference angle here. For 330 degrees, well, I can see that 330 degrees is in quadrant 4. So I need to figure out how far to go to get to 360. So it's going to be 360 degrees minus 330 degrees. It's going to give me a 30 degree reference angle. Because again, right, if I go 330, right, I'm looking for how much is left to get me to 360. And that's obviously 30 more degrees. 215 degrees, so that's in quadrant 3. So I need to go, well, I went too far past 180 degrees, right? So I'm wondering how much over 180. So 215 degrees minus 180 is going to give me 35 degrees. Basically, the way it works is if you're in quadrant 2, you do 180 minus your angle. If you're in quadrant 3, you do your angle minus 180. And if you're in quadrant 4, you do 360 minus your angle. Because you should always get a positive result. Here, 260 is just barely still in quadrant 3, so I'm going to do 260 minus 180 degrees to give me 80 degrees as my reference angle. Or you could draw it, right? 260, right? You'd be like, oh, I'm right there. And then that angle there, that's 80 degrees. Okay, other side. More of this, 135 degrees is in quadrant 2. Be careful with this one. 135 degrees is right there. And we're measuring this angle to the x-axis. And that angle is 45 degrees. Because 180 minus 135 degrees is 45 degrees. The reason I say be careful is because this angle measured to the y-axis is also 45 degrees. Right? 45 degrees is the one that splits 90 in half. But you're never measuring to the y-axis for a reference angle. You're always measuring to the x-axis, either 180 degrees or 0 or 360. We'll worry about 600 in just a minute. Let's do 210. So 210 is, I think we did 210 already. No, we did 215. So 210 is going to be 30 degrees over 180. So our reference angle here is going to be 180. It's going to be 30. That's our reference angle there. Again, you can see it. They're saying, okay, 90, 180, 30 more than 180. So that reference angle is definitely 30. Minus 120. So when you have a negative angle, it means you're going around clockwise instead of counterclockwise. So negative 120 is going to go, so there's negative 90 and then negative 30 more. So there's my negative 120. And I'm looking for this angle here. It's kind of funky. In fact, I'm having kind of a hard time thinking about how to do it exactly. I would probably just want to say, well, it's 60 degrees because I need to go 60 more degrees to get to, I guess, to negative 180. So I would do, this is going to feel kind of dumb. Yeah. I want to know the difference between this and this. So the problem is, if I do it this way, if I do negative 180 minus negative 120, I end up getting negative 60, but our angle should be positive. You can either just take that and say it's positive, or you could do, I guess the technical work you should do is negative 120 degrees minus negative 180 degrees. So if you do that minus that, you end up with this angle here, which is 60 degrees. 600 degrees is more than a full revolution. 90, 180, 270, 360, 450, 540, and then a bit more. So to find my reference angle here, what I should really probably do is actually find the smallest co-terminal angle that's still between 0 and 360. So I can do 600 degrees minus 360 and get 240 degrees. And then I can find the reference angle for 240, right? Because this is 240 and this is 600, which is the same angle, just different. So the reference angle for 240 minus 180 would give me a 60-degree reference angle. So that's how you find reference angles using degrees. And really, it's the same process for radians. It's the numbers just look different. But you're always trying to find the smallest angle measure that will get you to the nearest x-axis. So you're either going down to 180, back up to 180, or back up to 360.